Hi everyone, can you hear me?
Yes, sir.
Okay, okay. So let's get started. So today, basically, this session is hosted by Gate Overflow, and here we will be discussing probability. So I thought that since probability syllabus is little long, so I thought that we can have it in two sessions. But this is more like general session in the sense that no, we will not only discuss the probability, we will also discuss that whatever your general doubts are related to engineering mathematics. Okay, so maybe it is preparation related, maybe it is related to technical doubt or something. So we will be discussing all of things. So what do you want me to first take your doubts, or do you want me to first revise some concepts, and then I can take your doubts? So it may be non-technical doubt, it may be technical doubt. So everything we will be covering related to engineering mathematics specifically. And also, if you have any other doubt related to your preparation, you can just ask me. So what do you prefer? Okay, this session is going to be for 2 hours. Maybe for first 1 hour, I can just revise you few concepts of probability, and then we can then later on take your doubts. Is this fine? Okay. So like if you talk about gate CSE syllabus, so this is by the way session for gate CSE aspirants and for gate D aspirants also. So if you're gate D aspirants, then only you can then also you can basically take this session, because in this session we will not only discuss we will not only discussing the gate CSE stuff, because gate CSE stuff is anyway subset of gate DA, right? Which means this whatever we are going to discuss will anyway be in the gate DA if it is in gate CSE for engineering mathematics. Okay, so the session is for both. Okay, gate CSE and gate DA aspirants. Okay. So this is the syllabus for probability. Mainly, they ask the questions from conditional probability based theorem and these random variables or the distributions. So in this session, since the probability is little big to cover in just one session, in this session we will cover everything till random variable. In the sense that I will not be discussing specifically this uniform or normal or this these distributions. I will be covering these random variables. I will be covering conditional probability based theorem and few other things about the probability. Okay, but I will not be covering this uniform, normal, exponential. This we can cover in the subsequent session. Okay, whenever it is. So let's get started. Now, what is a probability? Suppose if I say that probability of getting head is 1/2, then what does this mean? Does this mean that we are saying that if you toss a coin two times, you will be getting one time head? Are we saying something like this? So you can speak and you can just discuss the things. Let me know. Are we saying something like this? That if we
Sir,
toss a coin
we are
two
not
times.
able to see the screen, sir. Slide is not visible.
Yes, sir. Whatever you are writing, it's not visible.
Okay. So currently, what you're seeing on the screen?
Nothing. Your face is visible, sir.
Oh, okay, okay. I thought the slide is visible. Mhm. In just a second. Now is this visible?
Yes, sir. Is it visible now?
Okay, 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 okay. Sorry. So I was just saying here that suppose that you are gate DA aspirant also, then also you can basically take this session, because this session will be, in this session we will be covering the concepts which are related to these topics, and which are in the common for gate CSE and gate DA both. For example, the topics that we will be covering accept these topics, right? These special type of distribution that I will be covering later on. But apart from this, we will be covering everything in this particular session. So let's get started. So suppose we are saying that probability of head is 1 by 2. Okay, probability of appearing head on a toss of fair coin is 1 by 2. Then what does this mean? Are we saying that if you toss a coin two times, then you will be getting a head one time? So suppose the probability is half, then does this mean that after tossing two times, you will be definitely getting one time head? No, right? So what does this actually mean? Okay, let me just ask it again. Does this mean that if you toss it four times, then you will be getting two times head? Or maybe does this mean that if you toss eight times, you will be getting four times head? The answer is no, right? So basically, if you're tossing it basically eight times, then also there is no guarantee that you will be getting four times or two times or something like this. Then what does this probability mean? Can anyone tell me quickly?
Sir, it definitely means that when we toss the coin enough number of times, then the expected outcome of getting the heads on the coin, it's close to 1 by 2.
Yes, right. So if we toss enough, right? So for example, people have actually tossed it enough times. For example, there was some statistician. He has tossed 24,000 of times. Okay, and then out of it, approximately 12,000 of times he has got head. Right. Similarly, one of the other author has tossed, let's suppose, 2,000 times, and then approximately 1,000 times he has got head. So basically, it is like if you toss it enough times. Now, what is this enough? Okay, so NF is not a number, we cannot quantify it. It is just that it is a theoretical way of saying it, that if you toss it enough time, mathematically you can say NF is always n tends to infinity, which means if you toss it many times, then you will be getting very close to 1 by 2. Okay, the ratio will be 1 by 2. That is what probability mean. Okay. Now let's just go to the next slide. So what is the sample space? Sample space is a set of all possible outcomes that you can get. For example, if you are tossing a coin, right? Coin toss. Then what are the things that you can get? The possible things that you can get is head and tail, right? So basically, this is the sample space. Now you can say this is sample space. Okay. So since it is a revision session, that's why I'm just quickly going through the things. So whatever experiment you are doing, the experiment means the coin toss or maybe the dice throw or whatever, right? Whatever experiment you are doing, out of it, whatever the possible outcomes is called sample space. Okay. Now, if in this sample space, if you group the things, for example, you say that, okay, let's suppose if you are throwing a dice, okay, then 1, 2, 3, 4, 5, 6 is possible. And then you can say that, okay, even numbers is one group, odd numbers is another group. Then if you group it, okay, then it will be called event. Okay, it is a subset of the sample space, that is a collection of possible outcomes, is called event, right? So, for example, as I told you that if you are tossing a dice, then 1, 2, 3, 4, 5, 6. These things are possible. So now you tell me, can this be one event, event A, and can this be one event, event B? Yes, this is definitely possible, right? Can I define event B something like this, which is taking something of event A also? Let's suppose three is common in event A and event B. Can I define something like this? Yes. So we can define any event. I mean, event definition is this: a subset of the sample space that is a collection of possible outcomes. It doesn't say that, okay, two events can't be having anything common. They can definitely have any something common, right? Okay. And now there is a term called probability. So we define probability over the events. So the probability definition, probability is a basically function, right, that maps an event to 0 to 1. So probability is something like this: probability of, okay, someone is doing some annotation or something. I'm basically, this pen is little slow. Just a second. Let me just off the annotation or something. Mm, okay. Okay, let's just see if it is fine. Someone is using the pen, right? Because okay, let's just check. So if I say that that there is a probability, see someone is I think doing something, right? So I think there's an option to stop the annotation or something like this. Let me just check.
Sir, there are three dots there na before end call. There
Ha
you will
ha
get the. Sir, one thing, sir, like I am an enrolled student of Go classes. I
ha ha.
texted regarding group link for long back of 14 days, but I didn't receive any
Which link?
information for group link, private group community for Get CSC.
Okay, you can mail us for that. Like over the mail, we will provide.
Yes, sir, I did 14 backs before itself, 14 days.
Okay, if that is missed, you can just mail it again. That please provide me a link. Maybe by chance it is missed. They
Okay,
will they
thank
will
you.
just provide you.
Yes, sir. By the way, your OS is God level, sir. Thank you for that.
Thank you so much. Thank you so much. I think I found it. Okay. Yes. Thank you. Thank you for appreciating operating systems. Yes, it is actually one of the very good course that I have taught. Like I have covered many things over there that generally people don't cover. For example, system calls and these things, memory management in very good detail, semaphores and these things. Okay.
Multi-level paging and especially CN also. Lot of
Yes.
questions there. Around 400 questions in CN. No one will do that.
Yes. Yes, yes. So in actually in all the courses like be it operating system, be it computer networks, be it discrete mathematics, in all the courses we have covered many questions. And one thing you might have noticed that those questions are not redundant in the sense that we are not just changing the value and then asking the question again just to increase the count. The count increase is actually genuine. I mean there is no redundant increase of the count, which means every question is unique in their own way. Okay, so let's just continue here. So here, what I'm saying is that probability is a function that maps an event to 0 to 1. For example, if I ask the probability of A, then probability of A will be from, I mean, it will depend on the question, but it will be something from 0 to 1, right? 0 to 1. Now, now this A has to be event. That's what I'm saying. It has to be event, right? So basically, if you treat it as a function, P is a function from event to 0 to 1, right? Okay. So, by the way, a function is from a set to a set. So, can you tell me what are the possible events? Like how many subsets that are possible? If let's suppose sample space size is this omega, then how many subsets are possible? The number of subsets which are possible will be 2 power omega, right? The number of subsets which are possible, which means you can say that these many events will be possible. Is this okay to everyone? If you are a little bit familiar about discrete mathematics, then you might have studied this number of subsets, right? How many of you have studied this number of subsets? You can just say yes or no. Okay, you can just speak up because this session is not for the writing. You can speak up and you can just let me know. You can just say yes. Okay, so you don't know that number of subsets are 2 power omega. Is this? So suppose that you have a set and then there are, let's suppose, n number of elements. Okay, a1, a2, an. Then maybe you can take this element or maybe you can not take this element. So basically there are two possibilities for this, possibilities for this, like this, right? So there are 2 power n, or if there are n number of elements. And similarly, if there are omega number of elements and there are 2 power omega number of subsets are possible. So that's why you can say that probability is a function That is 2 from 2 power omega to 0 to 1. I mean, that's a mathematical way of saying it, but you don't need to know it for your gate exam. But I'm just saying it that it's a mathematical way of defining the probability. Is this fine to everyone? Okay. So now, having defined the probability that it is from an even to 0 to 1. Now let's just quickly go over these slides. So you know that probability has to be greater than or equal to 1, and summation of all the probabilities, or the sample space probability is always 1. And if two events, this is very important, which is these are the axioms. Axioms means that these are the base of the probability, which means anything in the probability has to be proven through this. Okay. Like whatever is the new theorem, whatever is the new law, whatever you study has to be proven through this. So additivity means that if two events are mutually exclusive, for example, this is one event and there is one more event which is not having anything in common, which means let's suppose this is having 1 2 3 and this is having 4 5 6, it is not having 3 in common or neither anything else in common. So in that case you can say if this is A, this is B, probability of A union B, it is probability of A plus probability of B. Okay, this is very important. If all events are equally likely or all outcomes are equally likely, then probability of any event is number of elements in that upon total number of sample space points. For example, if I just ask you that this is one event, right? This is one event A, this is another event B. What is the probability of A if 1 to 6 are equally likely? What is the probability of A? How many numbers are there? 3. How many total numbers are there? 6. So it will be 1 by 2, right? Is this fine to everyone? Okay. And if let's suppose there are different probabilities, let's suppose this is see currently all are having equal probability, but let's suppose this is 1 by 6, but this is let's suppose 1 by 8 or something, right? I mean, if there are different probability, then what will the probability of A? You can just sum this up. Okay, you can just sum this up. Let's suppose this is also 1 by 8. You can just sum these probability and then you can find out the probability of A. Why? Because this disjoint rule or additivity rule, because every sample space is anyway disjoint, right? So probability of this plus probability of this plus probability of this. Okay. So maybe we can directly talk about the questions. Now let's just see this question, which has been asked in GATE 1997. So do you want to try this question? What this question is saying, probability that it will rain today is 0.5. Okay, so probability that it will rain 0.5. The probability that it will rain sorry, it will rain today. Okay, so it will rain today at 0.5. If it is not visible, let me just write it again. So probability that it will rain today is 0.5. Probability that it will rain tomorrow is 0.6. Probability that it will rain either today or tomorrow. So okay, let me just rain today. Okay, maybe I can call it rain today or tomorrow. So what should I write? Or means union or intersection? Rain tomorrow. What should I write? Can you tell me? It will be union or intersection. What do you think? Let me know. So it will be, yeah, union, right? Is this fine to everyone? Okay. Actually the chats are not visible to me. So maybe I can. Is there a way to pull this chat on the screen? Okay. So I think I need to keep on switching to check the chat, but that's fine. Okay. So basically, what I'm saying here is that if this is the question, then you will be saying that okay, it will be union. Now, what they're asking that and means intersection. Okay. Now they're asking this the probability that it will be A intersection B. So what is the formula of this? Probability of how probability of A intersection B and probability of A union B are related. That is called inclusion exclusion formula. So basically, A union B is basically A plus B minus A intersection B. That's very easy proof that we have done in the class, but now I'm not going to do it. So basically, it will be A union B will be A plus B minus A intersection B. So I think union probability is given, which is 0.7, right? And they're asking for intersection probability. So you can just add it 0.11, sorry, 1.1, right? and then minus 0.7. So I think 0.4 will be the answer. Is this fine to everyone? 0.4 will be the answer. Now let's just go to the next question. So in this question, they are asking probability of A union B. So here I think they will be you are having this, A complement and B complement. So you need to basically first find out the probability of A and B, because everything is in A and B. So you can first quickly find out the A and B. So probability of A is 2 by 3, probability of B is also 2 by 3, right? And now you can solve this question. Okay. So can I leave this question as an homework? So I think it will be easy to solve, right? Okay. So how to solve? A union B will be probability of A plus probability of B minus A intersection B, right? So it will be 4 by 3 minus 1 by 2, which is 8 minus 3 by 6, which is 5 by 6. Hmm. I think B is the answer, right? Okay, 10 by 12 or 5 by 6. So maybe they have solved it using other method, but that's fine. Okay. Now let's just talk about the conditional probability. So what is the conditional probability? Is basically that if you know some information, right? Let's suppose that you know some information and then you want to know about the probability of any other event. For example, let's suppose that I say that assuming that India and Australia are having the equal probability of winning, right? And if I just say that before start of the play, and what is the chance of India winning? Let's suppose that we are saying 0.5. I mean, there is no biasness, right? Now, suppose that India scores 395, and because India inning was first, and India scored 395, then what is the chance of India winning? Then probably you will say it is a higher chance, right? So basically, earlier India winning, let's suppose this is a event. India winning probability was 0.5, but now India winning probability, which means probability of A earlier, which is it is also called prior probability, it is 0.5, right? Now probability of India winning only, but given that it has scored 395, right? Probably you will say, probably you will say the now the probability is basically increased from 0.5, right? It will increase from 0.5, which means that probability of any event, given that there is some another event has been happened, that's called conditional probability. Okay, so maybe we can see with the example. For example, we consider the following situation: we throw two dice, we look for the probability of sum of the two faces 9. Okay, so if you calculate this probability, sum of two face is 9, is basically 1 by 9. Why? If you are basically tossing two dice, can you tell me what are the pairs where you will be getting 9? So I think with 1 you cannot get 9 because 8 is required. With 2 also you cannot get. With 3 you can get 6, right? And then with 4 you can get 5, and then with the 5 you can get 4, with again 6 you can get 3. So these are the 4 pairs out of 36 pairs, right? So which means 1 by 9, right? So this is the probability of getting summation as 9. Now, if they ask you that the one of the information is given that if the first face is 4, okay, which means you will just rule out everything else. Okay, you will just rule out this. They are saying if the first face is 4, then okay, so basically there are many other possibility. If the first phase is 4, then what is the probability of getting a 9? Then this probability is basically the first phase is 4, then these are the events, right? So the probability of getting 9 is basically out of this. You can just check. 9 is basically coming out of just one, right? So out of 6, 9 is just coming through this one. So you can say 1 by 6 is the probability. Okay, is this fine? So basically, what I'm trying to say is that if you know the probability of any event, then the subsequent probability is basically changing in the sense that it is called conditional probability. Okay, so probability of A might be different than probability of A given B. Okay, these two may be same or may not be same. In general, these are not same. Okay. So now let's just see this question. What they're saying: a die has been rolled where the additional information is given that experiment has produced an even phase. Okay, there was a single die, and it has been rolled, and then there was an even phase. What is the probability that the two has occurred? Can you tell me quickly? Maybe I can open chat uh, on this mobile. It will be helpful. Okay. So you people are getting what is the answer? So let's just try solving this question. 1 by 3, right? Okay. You people are getting 1 by 3 as an answer. Okay. My voice is okay, or there is some echo or something? Can you just confirm? Because I opened it in one more place. Okay, this is fine. Okay, now let's just continue. So basically, what they're saying that a die has been rolled, and the additional information is also given, right? So here they're asking what is the probability that two has occurred. What is the additional information that it was even phase? So basically, out of 1, 2, 3, 4, 5, 6, they are saying that it was even phase, which means either 2, 4, or 6, right? These three has occurred. So now you can say that okay, if I just ask you, okay, what is the probability of two, given that even phase has occurred? If I just ask you this probability, okay, then this will be different. This might be different from probability of two. Can you just tell me probability of two? It will be a very simple probability, which is 1 upon 6, right? But given that even phase has occurred, right? Now in this case, you have just 2, 4, 6 in your sample space, right? Which in the sense that you have this only sample space. So here the probability of 2 will be, if everything is equally likely, then 1 by 3, right? So let's just try to understand this bit more carefully, and here we will just understand this conditional probability very, very clearly. Okay, so these are the 6 outcomes that we have currently. Can you tell me the probabilities of each of this outcome? If nothing is given, then the initial probabilities are 1 by 6, right? Everyone is having initial probability 1 by 6. Okay. Now, what they're saying that even phase has occurred. So basically, this has not occurred. This has not occurred. This has not occurred, right? So basically, whatever has not occurred, maybe I can just say that if I'm, talking about the conditional probability, then let me just define something called reduced sample space. Okay. Here I will say that this has not occurred. So the probability of this is zero. This is zero. This is zero. Now, can you tell me what will the probability of 2 in this reduced sample space? Reduced sample space means here some of the probabilities are zero basically. Okay, I mean you are just taking some part of it. So can I just say that in the reduced sample space also the probability of 2 is 1 by 6? Probability of 4 is also 1 by 6. Probability of 6 is also 1 by 6. The answer is no. So basically, in the reduced sample space, what is this probability? That's what is asked in the question, right? So what is the answer here? See, it is 1 by 3, but we need to answer it very carefully that why this is 1 by 3. See, whatever is the earlier probability, right? It is 1 by 6. Whatever is the earlier probability, you can write it, right? But tell me, if you say that this is, reduced sample space, in this reduced sample space only 2, 4, 6 is there, right? Is this a valid probability distribution in the reduced sample space? Is this a valid probability distribution? No, right? For the valid probability distribution, the summation should be 1, right? Great. So as Manish is saying, the summation should be 1. So basically, since it is not valid probability distribution, you need to divide this 1 by 6 by the normalization factor. The normalization factor means you need to sum this up so that ultimately summation will be 1, right? So basically, you need to divide everything with something like this, right? So if you divide this, you will be getting 1 by 3 as an answer. Here also 1 by 3, here also 1 by 3. So what I'm trying to say here is that if earlier whatever is the probability, now if you want to find out new probability, you can copy the old probability, no problem. But then you need to normalize this. For example, if I just ask you, maybe let me just give you the example. If I just ask you, let's suppose these are the few outcomes which are possible. Okay. Now, S1 is possible, S2 is possible, S3 is possible, S4 is possible. Let's suppose these are the possible outcomes. Now, suppose the probabilities for S1, S2, S3, S4 like this: 1 by 4, 1 by 8, 1 by 4, 1 by 8, 1 by 8, 1 by 8. Okay. So basically, everything I have taken as 1 by 8 except these two. Okay. You can quickly check whether these probabilities are summing up to be 1 or not. So most probably these are summing out to be 1, right? Now, suppose they say that S1 is not possible. Okay, S3 is also not possible, and S5 is also not possible. Can you tell me in the new sample space what is the probability of S2? What will this number? See, see what I told you, that you can copy this 1 by 8 as it is, not an issue, right? I mean, if I just ask you what is this number, then what are the steps? You can copy this 1 by 8 as it is, this 1 by 8 as it is, this 1 by 8 as it is. But since these are not summing up to be 1, you need to sum this up. It is 3 by 8, so you need to divide by 3 by 8 also. Is this fine? Right? So you need to divide by 3 by 8 also. So basically, okay. So here, which means divide by 3 by 8, it will be 1 by 3, right? So final answer is 1 by 3. Similarly, here final answer is 1 by 3. Here also final answer is 1 by 3. Now consider another case where you are having something like this. I mean, let's suppose they are saying that in your new sample space, okay, in your new sample space, uh, this is possible. Okay, this is possible. This is also possible. Let's suppose this is also possible. Now, this is not possible. Okay, I mean, let's not even further discuss this. So these three are only possible. Can you tell me what is the probability of, let's suppose, S3? What is the probability of S3? So first you need to sum this up. What is the summation of this? This is 2 by 8 plus 2 by 8, 4. This is 5 by 8, right? First you need to sum this up. So probability of S3 will be 1 by 4 divided by 5 by 8, which means multiply by 8 by 5, which means 2 by 5. Is this fine to everyone? Let me know. So how we are calculating the new probability is fine. Okay. So now you understood that how to calculate the probability in the new sample space, right? So basically what you need to do, you need to normalize also, right? So whatever is the old probability, you also need to normalize. Okay, that's all. Now let's consider next question. What they are saying: experiment has produced number less than 4. Okay, what is the probability the 2 has occurred? Okay, so basically they are saying that 1, 2, 3, 4, 5, 6 was there, but these two probabilities are anyway 0. So only these are remaining. So out of this, what is the probability that 2 has occurred? So you can directly solve this. I mean, since everything is equally likely, so out of this 4, so again everything is equally likely, right? So what is the probability that 2 has occurred? 1 by, okay, less than 4. Less than 4 means this 1, 2, 3. Okay, what is the probability that 2 has occurred? 1 by 3, right? Very simple. Okay, is this fine to everyone? Okay, great. Now let's just move to the next question. I mean, here also you can do the same kind of analysis, in the sense that you can say that, okay, these are the so basically these are the initial sample space 1 by 6, 1 by 6, 1 by 6, and then if you want to find out the probability of this, 1 by 6 divided by 1 by 6 plus 1 by 6 plus 1 by 6, which is 3 by 6, right? Then also you will be getting 1 by 3. But yeah, here it is very much clearly visible that since everything is equally likely in the reduced sample space also, so that's fine. I mean, you can, instead of inheriting the probability from the original sample space, you can directly calculate it 1 by 3. Okay, so here we are not inheriting the probabilities because it is unnecessarily a lengthy calculation. We know that in the reduced sample space also everything is equally likely, so directly 1 by 3. Okay, is this fine? Okay, so I hope it is fine to everyone, right? Great. Now let's just move to the next question, probably, or maybe just give me a second. Just give me a second. Okay, so have you understood this? What I'm trying to say, that you can directly say here is it is 1 by 3, right? Or maybe if you want, see here they're asking probability of 2, given that either 1, 2, or 3 has occurred, right? So there is a formula. Okay, so see, whatever I just told you is basically intuitive way, which means that either you can work with the reduced sample space like this, or maybe you can directly say it is 1 by 3, right? But there's a formula of doing it. What is that formula? Let's just see this, right? Probability of A given B. So probability of A given B, as you know, that you it has to be normalized, right? So it will be basically probability of A intersection B divided by probability of B. Okay. So this is the formula of conditional probability. Now let's just see that how we can use this. Okay. Maybe I can just show you how we can use this in this particular case directly. And then we will be moving to something called as tree diagram. Okay. So it will be probability of 2 intersection with 1, 2, 3, right? Because that's the formula divided by probability of 1, 2, 3. Now there is nothing called as reduced sample space or something. It is everything which is every probability is always in the original sample space here. Okay. So here it will be what is the intersection? It is just probability of 2, right? So probability of 2 divided by probability of 1, 2, 3. Now, what is the probability of 2 in original sample space? It was 1 by 6. What is the probability of 1, 2, 3? In the original sample space, it is 1 by 2, right? I mean, 1 by 6 plus 1 by 6 or 1 by 6, or maybe out of 6 elements, 3 are chosen. So 1 by 2. So it will be again 1 by 3. Understood? Okay. Now let's just move to tree diagram. Okay, it is one of the best tool to solve questions related to Bayes theorem. So let's just see that what is this and how to use this. So for example, if I'm just saying something like let's suppose that head may appear or tail may appear, then I will be just making a tree out of it. Here I will be writing the probabilities. Okay, here I will be writing the probabilities. Okay, probability of head, probability of tail, like this. Let's just see the example. Suppose that I'm flipping it multiple times. At first flip had probability 0.5, 0.5. Then also let's suppose that each flip is independent of each other. Then the second flip also 0.5, 0.5, like this, right? So basically this will be the tree diagram for the for flipping twice. Okay. So now let's just solve this question. Suppose they are saying that you are off to soccer and love being a goalkeeper, but that depends on the coach today. With coach Sam, the probability of being the goalkeeper is 0.5. With coach Alex, the probability of being the goalkeeper is 0.3. Okay, and probability of Sam being coach is 0.6, and then obviously the probability of Sam Alex being coach is 0.4, right? 0.4. Okay. So what is the probability of that you will be the goalkeeper today? Can you tell me? See here first tell me that which event has occurred first. Your goalkeeper first or the coach has been assigned first. Obviously, based on the coach, you will be the goalkeeper, right? Based on the coach. So in the tree diagram, okay, always I mean have the intuition that which event is happening first. So since the coach will be selected first, so basically just make a tree diagram starting with the coach. Either Sam will be coach or Alex will be coach, right? Now if the Sam is coach, okay, your goalkeeper with 0.5 probability, okay, then you can just expand this. Your coach with 0.5 probability, okay, with Alex being coach, your goalkeeper with, sorry, your goalkeeper, not coach, your goalkeeper with 0.3 probability, right? Now you tell me that this probability, let's suppose, see, it is given 0.3 here. Now you tell me that are these two probabilities related, which means summation should be 1, or anyhow this probability is influencing this probability? Tell me, anyhow. Is there any chance that this probability is influencing this probability? Are these probabilities are dependent in some sense? No, right? So these two probabilities are completely independent in the sense that this number will not be influencing this number. So basically, it is completely a different domain, or a reduced domain, you can say, or reduced sample space. Basically, this is completely a different reduced sample space. Okay. So these two probabilities will not be influencing each other. Now, they're asking what is the probability you will be goalkeeper today? Okay, so they're asking that what is the probability that you will be goalkeeper? So basically here, not a goalkeeper. Okay, not goalkeeper. Here you can say this is 0.7, this is 0.5. Okay. Now what is the probability that you will be goalkeeper? So you can just select, okay, whatever the nodes are of your interest. So these two nodes are of your interest. Then multiply all the probabilities till this node. So basically 0.6 into 0.5 plus 0.4 into 0.3. So what does this probability represent? This represent that your goalkeeper and Sam is a coach. This represent your goalkeeper and Alex is a coach. Okay. So we will talk about the representation in a while, but here I'm just trying to tell you that whatever is a node of your interest, you just sum all the probabilities till that node. Okay. Multiply all the probability till that node, and then sum all of these different nodes. So what is the answer you're getting here? Okay, 0.42. Okay. So basically, in general, a tree diagram looks like this, where you will say that, okay, maybe three event has occurred, right? A1, A2, A3. Then let's suppose here, maybe B1, B2, or you can call it B and B complement, or maybe B1, B2, B3. Here, then again, 2, 3, 5, whatever number of the events may occur, right? And then this is a node which is representing A1 and B. For example, in the previous case, it was representing you are a goalkeeper when Sam is a coach and you are a goalkeeper. So basically, the nodes are representing the meaning. Okay, so the intersection. So nodes will be intersection, and here we will be writing the probabilities. Okay. Now, interestingly, this probability. Can anyone tell me what is this probability? If you remember, this probability will be probability of. Can I say probability of B? Can I say probability of A, or A intersection B, A1 intersection B, something like this? This is basically, since this event has occurred, this probability here, I will be always writing the conditional probability. Okay. On the edges, I will be writing the conditional probability. So what is this probability? Since A1 has occurred, what is the probability of B? Okay. On the edges. So for example, here you might not have noticed, but here also I've done the same thing. Can you tell me what is this probability? This 0.3?
0.3.
Hello? Okay. So what is this probability? This probability is probability of C. This will be the conditional probability that Alex is a coach and you are a goalkeeper. This is always on the edges. I will always writing the conditional probability. Okay. Here there is no condition to start with, but after that there will be the conditional probability. Okay. So now you tell me that the probability that X represent, what will that? The probability of just A1, right? Probability of just A1. This X represents the probability of just A1. Similarly, if I just ask you, what is the probability that Y represent, it will be the conditional probability. Can you tell me what is this? This will be given A1, the probability of B2. Given A1, the probability, yeah, C, right? Okay. Can you tell me what is the what does the Z represent? Given. See, this is very interesting. Given A1 and B2 both. Okay. What is the probability of C1? C1 given A1 and B2 both. So D is the answer here. Okay. So these are the 3-4 questions to check your understanding. For example, here the circle node represents. See, uh, see, X, Y, Z are the conditional probability. But if I just ask you the probability of a node, for example, if I just ask you what does this, what probability this node represent, this will be a joint probability. Joint probability in the sense the probability of A1 and B2 and C1. Okay, A1 and B2 and C1. So C is the correct answer. So now is this clear to everyone that how the tree diagram is working? So the nodes will be representing the joint probability and the edges will be representing the conditional probability. Okay. Okay. Now let's just solve this question. An urn contains 5 red balls and 2 green balls. A ball is drawn. If it's a green, if it's a green, a red ball is added to the urn, and if it's a red ball, if it's a red, a green ball is added to the urn. Okay. So basically, there are 5 red balls and 2 green balls. Now you're drawing a ball. Okay. So the opposite color will be added. If you are basically if the ball drawn is green, then the red will be added, or if it is red, then green will be added. The original ball is not returned to the urn. The second ball is drawn. What is the probability that second ball is red? Okay. Just try to solve this question. So maybe since it is very first question, so maybe I can just try to explain this, that what is happening here. That first you are drawing the first wall, right? So you can just make a tree diagram, that here I will be adding the first wall. So first wall could be red. See, total number of red walls are 5 and total number of green walls are 2, right? Okay. Now first wall could be red or it could be green. If red wall is there, then second wall. Now I will be writing the second wall on the uh, on this particular column or here. So basically this is for the second wall. Now second wall can again be red or can be green, again be red or can be green. Now if it is, so first tell me what is the probability of red. It was 5 by 7, right? Here it was 2 by 7 here. Now if the red is drawn, then these numbers will be changing, right? Red is just 4 and green will be 3. Is this fine? Right? Now what is the probability of red? It will be 4 by 7. Automatically these two probabilities are always 1. Okay, so automatically this is 4 by 7, then what will be the probability of this? This will be 3 by 7. Okay, I mean the probability of green is anyway 3 by 7. If the green is drawn, then these probability will be again changing, right? Then green will be just 1 green, but red will be 6. Then red will be 6 by 7, and then it is 1 by 7. So let's just first check if this diagram is okay to everyone or not. Okay, they have written it like this, but I hope that's fine, right? Now they're asking the what is the probability of this red. Okay, second ball is red. So your node of interest is this. Now what you can do, you can just multiply all of this probability and then you can sum this up, right? So the answer will be something like this. Were you able to find the answer? Okay, great. So Asif is saying that he got the correct answer. Now, I hope you understood that what is the tree diagram, right? Now we will be solving many questions based on the tree diagram. Let me first, define more of the conditional probability first. So basically, in the conditional probability, the axioms are same in the sense that it also follow non-negativity, normalization, and the additivity rule. Which means if these two are independent even, then you can just sum this up. Okay, sorry, not independent. These two are disjoint. Okay, then you can sum this up. Okay. So probably you might be knowing this, that if you want to find out the probability of B, right, then you can just divide this into multiple parts. Okay, you can say this is B intersection A1, B intersection A2, B intersection A3, like this, right? Where this A1 to A6 is forming a partition. Partition means this covers the sample space and these are mutually exclusive. Okay, A1 to A6 are basically the mutually exclusive and the fully fledged, in the sense that these are exhaustive and mutually exclusive. Okay. So if you want to find out the probability of B, so you can divide this into the basically this division is always there, right? This mutual exclusive and exhaustive division is always there. Then you can say probability of B intersection A1, B intersection A2. You can just sum this all of this, right? Okay. Now let's just solve this question using the tree diagram, and then you will get to understand the tree diagram more carefully, and then we will be solving gate P by quiz, okay, using the tree diagram. So let's see what they are saying. A bag have 3 balls. Okay, so I have 3 bags, and each is containing 100 marbles. Bag one is having 75 red and 25 like this. Okay, the information is given. I choose one of the bag at random and then pick the marble from the chosen bag. Okay, so first you're picking the bag and then you're picking the marble. So you always have to check what is the sequence, right? First you're picking the bag and then you're picking the marble. What is the probability that chosen marble is red? Okay, so first you're picking the bag, right? So either it is bag one, bag two, bag three. Then out of bag one, maybe red or blue, red or blue, red or blue. So your area or your node of interest is basically, you can say, red, right? So this and this. So you can sum all of these probabilities. Okay, and then you can get your answer. Great. Now let's just directly solve this gate question. Now this has been asking in 2018. So what they are saying, the consider Guwahati, Delhi, whose temperature can be classified as, so basically there are three type of temperature: high, medium, or low. Probability of Hg denotes the Guwahati has the high temperature. Okay, so the city name they are writing like this. So the probability that Guwahati has a high temperature is represented like this. Okay, probability that Guwahati has a medium temperature is represented like this, and so on. Okay, the following table is a conditional probability. This is the conditional probability table for the Delhi temperature is given. First row in the above table, the first entry denotes that if the Guwahati has the high temperature, then the probability Delhi also has the high temperature. Okay. If the Guwahati has the high temperature, so basically they are saying the first entry here is denoting something like this. Okay. This is the first entry, which means given this is always in the given. Okay. I mean, they have defined their notation, so don't worry about it. They will clarify that what this table is representing, right? Okay. So basically, what they're saying is that if you want to find out, right, then the probability that Guwahati has the high temperature, given that Delhi has the high temperature. Okay, so basically they are interested in finding out this probability, right? This probability, I mean, these probabilities are given. So basically, given that Delhi has the high temperature, so basically, I mean, given Guwahati has some temperature, then they have definitely defined it. But given that I mean, given that Guwahati has the high temperature, low temperature, they have defined it. But given that Delhi has the high temperature, they have not defined it, and then they're asking about this probability, right? So how to solve this question? Now, first you see that what is the sequence of events, right? I mean, here Guwahati has the high temperature, and these temperatures are given. See here that these temperatures are given. I mean, Guwahati, you can first do one thing, that either Guwahati will be having high temperature or medium temperature or low temperature. So you can do first this, right? Because these probabilities are given. So that's why it is better to first do this instead of. So what are the two options? What are the two options? Either this, or you can start with the Delhi, in the sense that Delhi has high temperature, medium temperature, or low temperature, right? So which one is preferred? See, this is preferred. Why? Because these probabilities are given, and also further, given Guwahati, things are given, right? Given Guwahati, so this is clear indicator that you will prefer this tree diagram. Okay. Now, now, basically, you will prefer this tree diagram in the sense Guwahati has high, Guwahati has medium, Guwahati has low temperature, and then Delhi can have high, medium, or low, right? Similarly, can have high, medium, and low. Similarly, can have high, medium, and low. Okay. Now these probabilities are given. So can you tell me what is the probability that it is given that, let's suppose if I just represent it here, what is this probability that Guwahati has high and Delhi has high, given that Guwahati has high, right? So this is the conditional probability, which is 0.04, 0.4. Okay. So this is the conditional probability, which means this probability is basically probability of Delhi has high temperature, given that Guwahati has a high temperature. What is this probability? Medium and then high, 0.1. What is this probability? Low and then high, 0.01. Okay. Okay, great. Now these three probabilities are also given: 0.2, 0.5, and 0.3. What they're asking is that they're asking about the reverse probability. Okay. So reverse probability is actually find out using the Bayes theorem. So I will just tell you how does this work. They're asking what is the probability that Guwahati has high temperature, given that Delhi has high temperature. Okay. So what is this probability? This will be probability of Hg intersection Hd divided by probability of Hd. Right. Now Do you know what is the intersection probability? It will be just one node probability. What is this one node probability? This is the intersection probability, right? So this will be 0.2 into 0.4. What is this HD? HD will be the multiple nodes probability. So this, and this, right? So it will be again 0.2 into 0.4 plus 0.5 into 0.1 plus 0.3 into 0.01, right? So if you solve this, you will be getting the answer. Okay. Answer, I think I don't have, but yeah. Answer I don't have, but can you tell me what is the answer you're getting? Okay, 0.6 is the answer, right? Okay, so if you solve this particular equation, then you will be getting 0.6 as your answer. Okay, 0.601, something like this. Great. Now let's just solve this question. What they're saying, P and Q are considering to apply for a job. Now probability that P applied. Okay, so both are considering to apply for the job. By the way, this question has been asked in 2017, and this is the year where I have appeared for GATE, and I for getting into admission to ISC. So at that time, I got a year 33. Okay. So in this year I have appeared. So probably this question was in my test. I don't clearly remember, but yeah, it was in my test most probably. Okay. I mean there were two sets, so either it was in set one or set two. I don't remember. So maybe if it is in set, I think I was in set two. I think, right. So if it is in set two, then it was in my test. Okay. So what they're saying, the probability that P apply for job. So probability of P apply for a job is basically 1/4. Probability that Q apply for the same job is 1/2, right? Sorry, this is a conditional probability. Uh, Probability that P apply for the job, given that Q apply for the job. Okay, probability of P apply for the job, given that Q apply for the job is 1/2. Is this fine? Similarly, 1/3 is the probability that Q apply for the job, given that P apply for the job is 1/3. Now, what they're asking is probability of P does not apply for the job, given that Q does not apply for the job. Okay, that's what they're asking. Now, let me just go to the next page and let me just ask you one thing. See here, which tree diagram will you prefer? Okay, which tree diagram will you prefer? For example, will you start from P apply for the job, or P does not apply for the job, and then Q apply for the job, and Q does not apply for the job, Q apply for the job, and Q does not apply for the job? Will you prefer this? You can prefer anything based on your convenience. Okay, which one, left one or right one? Is there any other probability which is given which we have missed? 1/4. I think that's all right. Which one will you prefer? Tell me. See, P apply for the job is given, right? Okay. So maybe you can prefer anything, right? Given P, given Q is also there. Okay. So maybe you can prefer anything. So maybe if I just say out of this information, can you find out what is the probability of Q? Let's suppose what is the probability of Q apply for the job? Let's suppose I'm preferring the second one. Okay. I mean, it is up to you. Whatever you prefer, the answer will be same. Let's suppose I'm preferring this. Okay. So what is the probability of Q apply for the job? I mean, because I will be needing it. See, probably you can do one thing using all of this information. You can apply, you can find out probability of Q apply for the job. See here, probability of P apply for the job, given that Q apply for the job is nothing but probability of P intersection Q upon probability of Q, right? Similarly, probability of Q apply for the job, given that P apply for the job is probability of P intersection Q, given that probability of P. So if you just divide both of this, right? If you just divide both of this, then I think this and this will get cancelled out, and you will get, so you will be getting, if you just divide both of this, probability of P divided by probability of Q, right? This was actually a tough question, to be honest. I mean, it was not very straightforward. So see, you have these two formula, right? Now what you can do, you can just divide these two formulas, and then you can find out the probability of q, because this term which is not given, it will anyway will cancel out, right? So if you find out the probability of q, you will be getting 1 by what is the number that you will be getting? 1 by 6, right? So you will be getting probability of q is 1 by 6. Now you have probability of q. Now you can maybe work with this kind of tree diagram also. So see, probability of q is now 1 by 6 that we have got. Now what you need to do, it will be 1 by 6. What will this probability? It will be 5 by 6, right? It is 1 by 6. It is 5 by 6. Okay. Now given that q has occurred, what is the probability of p? It is given as 1 by 2. And since this summation, okay, always has to be 1. So this is also 1 by 2. Given that uh, q prime has occurred, right? Given that q prime has occurred, okay, this probability is actually being asked, right? This probability, let's suppose this is, okay, whatever is being asked, let's suppose this is x, then this will be 1 minus x, okay? So basically this probability is being asked. Now how to solve for the x? Any idea? How to solve for the x? Maybe what you can do, you can say that, okay, probability of p is given, right? Then you can just multiply these two, and then you can find out the probability of p, which is 1 by 4. 1 by 6 into 1 by 2 plus 5 by 6 into 1 minus x is actually 1 by 4. From here, you can find out the value of x. Okay. So what is the value of x that you are getting? Or maybe you can find out the probability of p complement from this probability of p, and then you can directly use p complement this kind of chain. Okay. So whatever is easier for you. So x is coming out to be 4 by 5. Yes, x is 4 by 5. So is this fine? It was actually a tough question, to be honest, right? Here first you need to calculate probability of q, or given, I mean, you can use any of the tree diagram, but whatever you are using, you have to calculate the probability of q before even using the tree diagram. And after the tree diagram also, it was not very straightforward. You need to take one of the probability as x. Okay. So this was a tricky question, but using the tree diagram, actually it has got simple. Otherwise, it will be more confusing. Okay, if you just just use formulas here and there, it will be even more confusing. So this is another great question. Maybe you can solve this. Okay. Now let's just move to the random variables, right? So let's just define the random variables and what are the random variables and these things. Okay. Now, now you might have already studied the random variable already. So this will be a quick introduction to the random variable, that what are the random variables and how to solve the questions related to the random variable. So here the good news is that whatever we study, right, in the previous case where we have the events, this random variable is actually same as events. The only new concept here is mean and variance, these kind of things. Okay. So first let me just tell you what is a random variable, then you will be able to understand more. Random variable, let's suppose x is a random variable. Then random variable is basically something which map our sample space to a real number. For example, if my sample space is containing two outcomes, head and tail, right? Then x, let's suppose x is a random variable. Okay. So this is head and tail. If x is a random variable, x will be mapping. It is just like a function. It will be mapping head to some real number. It could be anything. It is based on your choice. Let's suppose 100. It will be mapping tail to something. Let's suppose any real number. Okay. 55, something like this. So random variable is actually a function, okay, which map a sample space, or the basically we have the elements of the sample space, right? So it maps the sample space elements to the real number. Okay, that is the job of random variable. Is this a little bit okay to everyone? Okay, so let me know. which is basically, it is basically mapping the, this is called outcome. Okay, outcome of the experiment. It maps the outcome of the experiment to the real number, right? Okay. So basically, what is happening here, that let's suppose you do some experiment, okay, and then you get some outcomes. Let's suppose the outcomes are W1, W2, W3. Then this random variable will be mapping to some real number. It can map W1 to something, it can map W2 to something like this. It is a function, right? Since it is a function, that's why it has to map everything. Okay, it will be mapping every of this. It will be mapping every of this to something, right? Okay. So I hope that's fine. Now, uh, maybe let me just define that. Let's suppose if I say that x is 5. Okay, let's suppose if I say x is 5. See, even though it is a function, still this kind of notation is very popular. Let me just tell you that what does this kind of notation mean. It means it is basically a set. Okay, it is a set of all outcomes where x maps outcome to the 5. Okay, set of all outcomes which x map to 5. For example, this is basically a set. So you can say it is a set of all outcomes where x w is 5. Okay, but we use this kind of notation because it is easier to use instead of using this kind of notation. So x equal to 5 is a set, and a set of outcomes is also called event, right? So this is also an event. So you can say it is also an event. Okay, is this fine to everyone? Similarly, not just equal, similarly, x less than, let's suppose, 100 or x less than 10, it is also an event. So it is also a set basically, which is all the outcomes where x map to less than 10. Okay, it is also, you can say, event, because it is also set of outcomes. Set of outcomes is also called event. Okay. So we can say that either you're writing x equal to 5 or x less than 5, greater than 5, whatever you're writing, right? So this is called conditioning on the, or putting the equality or inequality sign on the random variable. So any sign on the random variable is actually making an event. Okay. So that's why we can define a probability. We can define a probability of x being 5. We can define a probability of x less than 10. Why? Because probability is defined over the events. And this is an event, this is also an event. Okay. Is this little bit fine? Okay. So maybe we can just, you know, talk about it little more. So suppose that x is a random variable that takes a value 1 on the head and 0 on the tail. What is the probability of x being 1? Okay. So basically, x is a random variable that takes map head to 1 and tail to 0. Now, if we are asking what is the probability of x being 1, it means x being 1 means what? That all the outcomes where x map to 1. So can you tell me the list of outcomes where x map to 1? Only head, right? So what is this? If it is a fair coin, then this is 1 by 2, right? Is this fine? Okay. So basically, what I'm saying here is that head and tail are having some probability, right? 1 by 2, 1 by 2. These are the probabilities of head and tail. Now, these are where the x map to. Okay. Suppose x is mapping this to 1, this is to 0. Now, if someone asks me that what is the probability of x is 1, then you can say that it is same as head occur, which means it is 1 by 2. Okay. Now, it might be the case that multiple outcomes are mapping to the same number. For example, let's suppose this is S1, S2, S3, S4, S5. Okay, let's suppose there are only 5 items in your sample space or 5 outcomes in your sample space. Now, in that case, let's suppose these are the probabilities. Okay, and these are the map that X is mapping to. Let's suppose the probabilities are, this is 1 by 5. This is also, let's suppose, 1 by 5. Now, I think 3 by 5 is remaining. Out of those 3 by 5, okay, maybe I can just say This is 3 by 10. Okay. And then this is also 3 by 10. Then how much is remaining? You can just adjust here. So this is 2 by 10, 2 by 10, 2, 4, 5, 6, 7, 8, 9. Sorry, it is completed, right? Okay, so here, if this is also 1 by 5, how much is remaining? This is basically 2 by 10. This is 2 by 10. This is 3 by 10. This is 2 by 10. 5, 6, 7, 8, 9. 1 by 10 is remaining, right? Okay, so you can write that 1 by 10 here. Now, suppose X is mapping. Let's suppose this to 1, this to, let's suppose 0, this to 1, this to 1, this to 0. Okay, some mapping. Now, if I just ask you what is the probability of X being 1, then you need to add these three probabilities. Okay, you need to add these three probability, and then you will say 1 by 5 plus 3 by 10 plus 1 by 5. Okay, is this fine to everyone? Let me know. Okay, great. So basically, if I just ask you what is the probability of X being 1, then you need to collect all the outcomes which are basically which X is mapping to 1, right? But generally they will not give you outcomes and all. They will directly give you something called a probability mass function, which means they will directly give you this probability of X being 1 is what. Okay, you might not need to calculate it from the scratch. They will directly give you these kind of things. Okay, what is the probability of X being 1? This is called probability mass function. For example, if I just ask you what is the probability of X being X less than 1, let's suppose these are the 6 outcomes: X, S1, S2 and S6, which are equally likely. Okay, probability of X less than 1, which means what are the outcomes which is X is mapping to less than 1? I think only 2 outcomes, right? Still less than 1. So since there are only 2 outcomes out of 6, so 2 by 6 is the answer, right? X less than 2. So I think these are the 1, 2, 3, 4, 5 items. So 5 by 6 is the answer. X is between 1 and 2. I think 1 and 2 there is nothing, so 0, right? Less than equal to 4, all, right? So 5 by 6. It is 5 by 6, it is 1. Is this fine? Because everything is equally likely. Okay. Now let's just solve this question. What they're saying. Let's suppose they're asking let y equal to mod x, right? Then find out the y equal to 2. The probability of y being 2. So basically the probability of x is given, right? So they are saying that probability of x is 1 by 9. So x can have these values. X can have -4, -3, -2, -1, 0, 1, 2, 3, 4, right? These are the 9 values and everything is having equally likely probability. Okay. I mean, 1 by 9, 1 by 9, 1 by 9 like this, right? So the probabilities are just 1 by 9, 1 by 9 like this. Okay. Now, there is a by, right? By is a new random variable, which is mod x. This is a new random variable. They're asking what is the probability of by being 2. Okay. So basically, if you write the by, if these are the x values, then what is the y values? It will be 4, 3, 2, 1, 0, 1, 2, 3, and 4, right? So when is y2? Y is 2 here also, at 2 places. So you need to sum these two probabilities. Okay, you need to collect all the places where y is 2, which means y is 2 whenever x is 2 or x is -2. Okay, so this is a new random variable which we are defining. So if you want to find out the probability mass function for this new random variable, you can make a table like this, and then you can say that okay, the possible values of y is the possible value of y is 0, 1, 2, 3, and 4 only, right? And what is the probability of 0? Probability of 0 will be wherever the x is, I mean, the only place 0 can occur whenever x is 0. So it will be just 1 by 9, right? What is the probability of 1? It will be 2 by 9, because whenever x is -1 or +1, it will be again 2 by 9, it will be again 2 by 9, and it will be again 2 by 9. Right? This is the probability mass function of PMF of y. Okay. 2 by 9, 1 by 9, otherwise 0. Okay. So now let's just solve this question. Let x and y are the two random variable. Then they're asking find the probability of y being, let's suppose y being either 1 or 0. So for this question, you can say the y being 1. Okay. So probability of x being 0 and x being 1 is given. Z being 0 and Z being 1 is given. Right. And y is a random variable, which is x dot z. So you need to find out the probability that y is 1. So what you can do, one of the easiest ways is that x and z are the two random variable, right? Y is a x dot z. So what is the probabilities here? It is, let's suppose 0 0 0 1 1 0 and 1 1. You can just make a exhaustive table. Then it will be 0 1 1 and then 0, right? Now probability of x and z are the assuming that these are the independent random variables, okay? Because there is no dependence. So this is p, x 0 is p, this probability is p, and this probability is epsilon. Let's suppose they're asking probability of y being 1. So y is 1 at these two places. Can you tell me what is this probability? Y is 1 whenever this combination occur or this combination occur, right? So this combination means x is 0 and z is 1. So x is 0 and z is 1, right? Plus x is 1 and z is 0. Okay. So x is 0 and z is 1. So basically this is p and z is 1 means 1 minus epsilon. So p into 1 minus epsilon plus x is 1, which means 1 minus p into epsilon. Okay. Is this fine to everyone? So basically here what we are doing, we are finding out the probability of a new random variable, right? Which is a dependent on two other random variables, right? Okay, let me know. Okay, great. Now, uh, what could be the other method that you can think of to solve this particular question? See, this is very easy, right? Okay, sorry. One is here. I think yeah, that's correct, right? P into 1 minus epsilon into yeah, P into 1 minus epsilon into 1 minus epsilon into P. Now, suppose they ask you the what is the probability of y being 0, then basically you need to take these two rows, right? You need to take these two rows. Now, since x and z are independent, that's why you can directly say probability of x equal to 0 into multiplied by probability of z equal to 1, right? Since these are the independent random variables. Okay. But now suppose in this question only, they ask you this. What is the probability that y being 0, okay, or maybe y being 1, anything, but here it is a condition on given that x is 0. Okay. This is a new question, I can say, okay, or this is a variation. See, y is nothing but x dot z, right? Then can you tell me what is the probability of this? Basically, what you can do, you can just plug in this value, right? Okay. Now tell me what is the answer. So you can see x equal to 0 is given, right? So why you are, writing this x here. So instead of this, you can do 0 George z. So it will be just z, right? So probability of z equal to 0. But always keep this given, okay? Always write this given. Maybe z is also dependent. See, currently z is not dependent. So even if you not write this given, that's also fine, okay? But always first do step by step. Just always write this. So basically we are substituting first, right? And but we are not forgetting it. Then we later realize that z and x are independent, so it is just like this, which is given to epsilon. So it's very easy. Is this fine? So you can directly plug in the value, and then after that, just see if these are independent. Then you can just directly see the answer. Okay. So maybe we can solve one question here, which has been asked in gate. So what they are saying? x equal to 0, x equal to 1 is 1 by 2. Okay, so these are the three random variables, and everything has the probability as 1 by 2. And y is defined like some random variable x1, x2, George z3, your x3, right? And now they're asking the probability of y being 0 given that x3 is 0. So what is the buying? X1, x2, George z3, right? Equal to 0 given that x3 is 0. Now can you plug in this value? If you plug in this value, you will be getting probability of x1, x2 equal to 0 given x3 0. Okay, don't forget this given. Now you realize that okay, this is independent, right? I mean, since these are independent, that's why you can just because everything is independent, they're writing identically independent and identically distributed. Identically distributed means that all are having the equal probabilities. Okay, identical probabilities. Okay, so since these are independent like this, now again you realize that x1 and x2 are also independent, then you can basically okay. Just a second. You need to first tell that at what cases that x1, x2 will be 0. One of them is 0, right? Either x1 is 0, x2 can be anything. So basically it will be literated like this. X1 is 0, x2 can be 1, or x1 is 0, x2 can be 0, right? I mean, these are the basically four cases where these will be 0. So everything is having uh, yeah, so these are the four cases, right? And every case will be just 1 by 4 because 1 by 2 into 1 by 4 is this fine or there is something missing? So till now we have got, right? Now how to go further? These are the three cases, right? Yeah, that's fine. I think these are the three cases when x1 is 0, x2 is 1, x1 is 0, x2 is also 0, and when x2 is 1 and 0, and when both are 0, right? So these are the three cases here. So in these three cases only it will be 0. Every case is having 1 by 4 probability. So finally answer will be 3 by 4. Okay. It was also a good question. Is this understood? Right. So what you can do, you can also solve this question using a comprehensive table. I mean, it will be a long, but anyway, let's just try to see if we can solve 0 0 0 0 0 1 0 1 0 0 1 1 and then the same thing, right? So I think which one is given to be 0? X3 is given to be 0. Okay. I should have written x3 here, but anyway. Okay, let me just change this. Okay, let me just continue. So maybe 1 0 0. One, 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 one. Okay. So since x3, see, initially the probabilities are given to be everything is 1 by 2, right? So every row has 1 by 2 into 1 by 2 into 1 by 2, 1 by 8 probability, right? But x3 is given to be 0. So since x3 is already given to be 0, then you can say that x3 equal to 1. These are the ruled out possibility, right? This is not even the possibility. Okay. X3 equal to 1 is not even the possibility. This is also not even the possibility. And everything like this is also not even the possibility. Okay. This is also not even the possibility. Okay. So now you are in the reduced sample space. So can you work with the reduced sample space? They are asking the probability of by being 0, right? They are asking that in this reduced sample space, probability of by being 0, given that x3 is 0. Okay. So what is the probability of by being 0? Okay, so if you make this diagram or if you write the values here, so I think this will be 0 because y is defined as x1 x2 your x3, right? This will be 0. What is the value of this? I think this will be also 0. What is the value of this? This will be 0. This will be 1, right? Okay. So they are basically asking summation of these three rows, 1, 2, 3, right? They are basically asking summation of these three rows. Uh, can I just say that this is 1 by 8? This is also 1 by 8. This is also 1 by 8. Can I just sum this up? Tell me. See, this 1 by 8 was in the original sample space, but in the reduced sample space, in the reduced sample space, it will be 1 by 8 divided by 1 by 8 into 4, right? Which is 1 by 2, right? 1 by 8 into 4. Basically, again, you can say, see, you need not to inherit. Again, you can say, see, everything is equally likely. So 1 by 4, 1 by 4, 1 by 4. Okay. 1 by 8 was earlier, but now it is 1 by 4. Okay. So now it is 1 by 4. So basically, these were the earlier probabilities, but now you can say it is 1 by 4, 1 by 4, 1 by 4, 1 by 4. And now they're asking, in this new sample space, they are asking these three rows. So it will be 3 by 4. Okay. Earlier also we have got 3 by 4 using the usual method. So it is actually a short method. Maybe there are multiple random variables. So you might not able to do it. First plug in, substitute, and then finally you got this, right? And you're always in the original sample space. Then probably you can just make a table. If you want to make a table, you can just make a table for x1, x2 only, right? And then you can define a new random variable z. So I mean, when the product x1, x2, right? So 0, 0, 0, and 1. So when this product is 0, basically in these three cases, right? Out of the four cases, so 3 by 4. Okay. Okay. So now since it is 5:30, and yeah, so now we will be basically, probably there will be a next session there we will be discussing the random variable type, discrete and continuous. So today I have just discussed the basics and specifically Bayes theorem questions. Okay. Tree method and random variable, right? So these things we have discussed. Now you there will be one more session, and there we will be discussing discrete and continuous random variable, which means uniform position, these kind of random variables, and then we can just solve those questions. Okay. So these are the short sessions, in the sense that we are just revising, just solving the gate PO equation. Okay. Okay. So these sessions are actually conducted by Gate Overflow. And if there is any doubt related to preparation or anything, you can just ask me. So one of the students is asking when the subject-wise test of Go classes. So one of the tests was enabled today, and within a week we will be enabling all the three. I think three tests are remaining subject-wise. We will be remaining of that. Okay. Operating system was live today. I think you might have noticed it. Now there will be 2 to 3 tests are remaining, and those will be live in within a week. Okay. Okay. Now you can just speak up and let me know whatever questions you are having. Okay. Yes, recording will be available. So see, like with respect to the engineering mathematics, I can say that it's a scoring subject. Okay, for sure, it's a scoring subject. There will be definitely you can say 5 to 6 marks of questions will be there from engineering mathematics, and most probably you can score at least 3. In the sense that there might be one question which is very difficult from the probability, or maybe there might be a question which is very difficult from the calculus. Sorry, from the linear algebra. Generally from the calculus questions are easy. Okay. From the calculus generally questions are easy. So just try to do this particular subject. Do not skip this subject. At Go classes, I don't think it is very big subject, right? I think you can get 6 marks in 40 hours. Most probably it will be around it, right? If you just skip the live sessions or the doubt practice sessions like this, then maybe in the 30 to 40 hours you can cover all of this, right? So just cover this particular subject. Do not skip this subject, because there will be 5 to 6 marks of questions from this subject. Okay. And also there will be a general doubt discussion that we will be having before Diwali from the Go classes side also. So you can attend that session, and there also you can ask your doubts if you don't have currently doubts. So someone is asking, will there be a new Telegram private group for 2025 course? No, the private group will remain same, because there will be the seniors that they can help you, and there will be many other aspirants, they can definitely help you. So private group, we will not be changing it. Okay, it will be remaining same. Okay, so that's all for today. Maybe in the next session we will be just discussing continuous and discrete random variable, if there will be. Okay, I will just let you know if there will be a next session. Okay. Yes, recording will be shared with you guys. Okay. So over the Telegram, we will just share the recording. Okay. Thank you, everyone. Yes, annotated notes and recording both we will share. Okay. Thank you. Take care. Bye bye.